Okay, good morning. We are going to be working on lesson 3.5, solving equations with variables on both sides. First step, we are going to go ahead and put your name in class period on all of the pages. There are 4 pages to these notes. I promise you will survive. And I'm putting video to remind myself that this is my video copy. Okay, so first up, let's go ahead and talk about our vocabulary, our key terms here. First one is actually term. A term, we have reviewed this before, is a number or a variable or a product of the above. Remember that variables are letters and product means multiply. So some examples of some terms. We could have 3, we could have -6, we could have 1/2. Remember, fractions are numbers too. If we wanted to have just plain variables, we could have a, we could have -b would also be a variable. Could have x. Any letter could be a variable. And then any product of the above. You could have -2c. That means -2 times c. You could have gh. That means g times h. Or you could have 1/2 x. And that also means 1/2 x. So this is a bunch of different terms that we have here that are just examples. And remember, when you have a letter and a number mushed together like this, it means that it's multiplied. Same thing with 2 letters. 2 letters mushed together means that they're multiplied. G times h, -2 times c, 1/2 times x. Next up, let's talk about coefficients. The coefficient, just like we talked about earlier, is the number part of the term. Okay, so let's pull some examples here. We have -2c. Let's think about g. And let's think about 1/2 x. See if we can find all these coefficients. The number part of the term. So we have -2c. That means -2 times c. What's the number part here? Well, that's pretty easy. It's -2. Not 2, -2. This one's pretty easy too. We have 1/2 times x. What's the number there? 1/2. This one's a little tricky, but I bet we know if we think about it for a minute. What do we have? Oh, I almost said it. What coefficient, what are we multiplying this g by that doesn't change the amount or the value? It gets multiplied by a 1, so that is an invisible 1 for our coefficient. Okay, and last but not least, the variables are the letter parts of a term. So again, let's think about -2c, g, and 1/2 x. This should be a little bit pretty easy here. The letter parts of these terms are c, g. We don't even really have to think about the invisible 1 there because it's just the letter that I'm looking for the variable, and x. Okay, go ahead and catch up on those notes, and then hit pause if you need to, and then meet me back for the next section. So today we're talking about solving equations that have variables on both sides. So first, let's think about what we're doing when we're solving an equation. So we have an equation here. We have 3x plus 1 equals 4x minus 2. And the key here is that we do have variables on both sides of our equation. So we have, here's our equal sign, right? We have a variable over here, and we have a variable over here. Let's think for a minute about what this equation means. So when I'm looking at this equation, let's look at each side of it. Remember, we talked way at the beginning of the year about translating algebra into words and words into algebra. So let's translate this equation into some words, and I gave you some blanks here to work with. 3x plus 1. What does that mean? It means that you multiply a number, x, so that's what we're using for our number, x. We multiply it by 3, so that's where we get our 3x. Multiply a number by 3, and we do something else. We add 1. So you multiply a number by 3 and you add 1. That's what this side of the equation is talking about. Okay, we are going to skip to the other side of the equation where we have 4x minus 2. So now we have 4x. So you, again, let's look at our variable. You multiply that same number, x. So x over here is going to equal the same as x over here. In one equation, it's always going to be the same. Now, if these were x and y, those would be different. That x here equals x here. Okay? So you multiply that same number, x, so the same number that we multiplied over here, now we're multiplying it by 4. And what else do? We subtract 2. Okay? Give me just a second here. Okay, so once we have looked at what this expression 3x plus 1 and this expression 4x minus 2 equal, now we need to think about what this means. The equal sign just means that this that I underlined in green is the same as this that I underlined in purple. So it's the same as or equal to. Okay? So what we're trying to figure out in an equation like this, just like when we have variables on just one side, is we're trying to figure out what x equals. So what number can I put in for x that would make both of these sides, that would make these equal each other, that would make the green side equal the purple side? So let's think about that for a minute. If I have 3x plus 1 equals 4x minus 2. Well, I already kind of know some of my rules. I know that I need to distribute on each side. I need to combine like terms on each side. I need to add or subtract. And then I need to multiply or divide. The other trick, though, is a step that comes in here where I have to move variables to the same side. So let's try to figure that out. So I know that if I have 3x plus 1 equals 4x minus 2. I've got a variable over here and I've got a variable over here. Well, I want variables only on one side. So let's say I want to get rid of this 3x. I could say minus 3x minus 3x. If I do it to one side, oh, I forgot to talk to you guys real quick. There's no distribution I can do here, and there's no combining like terms on the same side. Okay, so now I want to get rid of my 3x. So I know that 3x minus 3x is 0. Just like if I just had 3 minus 3, I could cross it out. My 1 carries down. 4x minus 3x, I know that 4 minus 3x, 4 minus 3 is 1, so I have 1x minus 2. Okay, so this keeps on going down here because my negative 2 carries down. So we keep going down where we have 1 equals, I know that my 1x can actually just turn into an x minus 2. So now I've got my variables on the same side. So I dealt with everything and moved everything around. I've got variables on the same side. Okay, so I do have my 1 equals x minus 2. So now I can think, is there anything I can do to add or subtract? Well, I want to keep my x by itself, so I can get rid of this minus 2. I get rid of minus 2 by plus 2. One plus 2 is 3. My x carries down. My negative 2 plus 2 cancels out. X. So my 3 equals x. Okay, so I had to take a quick break, but now that we know that 3 equals x, we are going to go ahead and think about what that means in our equation up here. So what that means is that if I take 3 and I put it in this equation instead of x, or in this expression instead of x, and if I put it in this expression instead of x, it should give me equal values. So let's test that out. I know that if I do this side first, I have 3x plus 1. But if I'm checking to see if 3 equals x is going to work, I need to do 3. Remember, I do parentheses for my variables, and then 3 inside instead of x, because I'm using 3 instead of x, plus 1. I know that 3 times 3 is 9, plus 1. 9 plus 1 is 10. Okay, so if I use 3 as my x value, I know that it gives me 10 on this side. Let's see what it does on this side. Over here, I have 4x minus 2. So same thing. We're checking this side to see what does 4x minus 2 equal if I use 3. So if I have, so I'm going to go ahead and do 4, open parentheses for my variable, substitute in my 3 for my x, because I'm checking 3 equals x, minus 2. I know that 4 times 3 is 12, minus 2, and 12 minus 2 is 10. Well, looky there. I got them to equal. So if I use x equals 3, it will make both of these sides equal to each other, and that balances my equation. I have a much easier way that we can do this that I think you guys are going to like. So what we're going to do is make sure you've got that written down, and then we're going to jump to the next section. So this is the Desmos Magic. This is why I actually have Desmos pulled up. We're going to have some fun with this. Okay, so first off, this Desmos trick I'm about to show you works only if there is only one variable in my equation. So if I'm starting out with 5c minus 8, equals 11c minus 10 minus 2c, I only have c's in here. I don't have any other variables. They're only c. I can't just change letters around and make them different letters either, just to make this work. So you're given a starting equation. The first step is you're going to rewrite the equation, but you're going to change all of the variables to x. So up here where I had 5c, instead of 5c, I wrote 5x. My minus 8 stays the same. My equals stays the same. Instead of 11c, I write x. So my 11 stays the same. All I'm doing is changing that c to an x. Minus 10 minus, and that started out as 2c, but I just changed it to an x. So I had 5c minus 8 equals 11c minus 10 minus 2c. That sounds like a lot. I promise you can handle it. This step, super easy. You are rewriting it, but instead of what your variable was, you're making them all x. That's step 1. Step 2. This is where the Desmos happens. This is fun. Let me go ahead and change this around a little bit so we can see everything. Okay, so you're going to go to Desmos, the star version. Because it's the star version, that means you can do what we're about to do on the star test. We love it. Okay, so you have your starting equation. You changed all your variables to x. Now, you are going to put the equation in on two lines in Desmos. And you're using the equal sign to split it. So you have 5c minus 8 equals, not c, I'm so sorry, 5x minus 8 equals 11x minus 10 minus 2x. And you're going to split it at your equal sign. So if you see right here, I have 5x minus 8 on this side of my equal sign. I'm going to put 5x minus 8 on my first line in Desmos. So let's go ahead and do that. Let me make this a little bit bigger. So we have 5x minus 8. Oh my goodness, it gave us a line. This is so weird. It didn't give us an answer like we're used to. It actually gave us a line. Interesting. Okay, so we have our 5x minus 8. And now we need our 11x minus 10 minus 2x. This little line right here is just, I had a cursor in there when I did a screenshot. So that line right there in front of that 11 is not going to be part of your equation. So you're going to have 11x minus 10 minus 2x. So I want you to think for a minute. We are done with step 1 and step 2. None of what we have done has been super tricky, has it? All we've done so far, we rewrote our equation with different variables. We split it and we put it into 2 lines on Desmos. None of that is tricky. It's all super, super easy. We did not combine like terms. We didn't add or subtract. We didn't distribute. We didn't try to get something from one side to the other. All we're doing is you just, instead of c, you write x. And then you write this side on one line in Desmos and this side on another line. And now it gives you your 2 lines. You are looking for the intersection. For our last step, you are looking for the intersection on your graph. An intersection is where 2 lines cross. Kind of like an intersection, it's where 2 streets cross. So it's where the 2 lines cross. And you're looking for, since our red line here is one of ours and the blue line is the other one, you are looking for where the red line and the blue line cross. And you can zoom in, zoom out, all that stuff until you're comfortable seeing where it is. So you're going to hover and you're going to kind of click and it'll give it to you. It'll pop up this gray dot. Now, we've got a gray dot over here. Don't be confused because that's not where the blue and the red are crossing. We've got a gray dot up here. Again, don't be confused. That's not where the blue and the red are crossing. We're looking for where the blue and the red cross. We're looking for this one. This first number is your solution. It's what x equals. If you need to remember that, a little hint. You've probably seen points before that were written x, y. This is your x value. This is your y value. We're not worried about y yet, just our x value. Oh my goodness, what are we solving for? We're trying to solve for x. X equals 0.5. Which Miss McNabb does not like decimals. 0.5 equals, oh my gosh, hit the magic button. It is 1/2. X equals 1/2. Okay, so to review your steps, you have your starting equation. You change all the variables to x. You put each side on a different line in Desmos. You find where the lines cross, and you use the first number. That's your solution. That's what x equals. Let's do some examples. Okay. Example 1. Let's go ahead and there we go. Example 1. This is actually pretty easy because I know that all I need to do here is figure out, I don't have to change my variables at all, right? Because I already have x variables. I've only got x variables. So now I'm good there. So now the first thing I do is I put the equation on 2 lines in Desmos. And I know I'm going to split it with the equal sign. So this goes on one line. This goes on the other. I'm going to put 5x plus 6 minus 2x on one line. And I'm going to put -2 minus x minus 4 on another line. And I'm looking for what x equals. Let's see. Let me show you a trick in Desmos, guys. Now that we've got lines in here, if you want to not lose your work and keep working, you can click and it turns off that line. So you can still see what your work was, but that line isn't clogging up your graph. So if you want to turn off your lines, you can do that. And now we have 5x plus 6 minus 2x, enter, -2 minus x minus 4. Okay? You'll notice that some of these lines are now darker colors. If you want them back to different colors or anything like that, or it's hard for you to tell which line is which or where it crosses or anything, you can always change the color by clicking and holding and then pick a different color. I'm going to pick green and orange. Okay? So I've put my equation on 2 lines in Desmos. Now I need to find the cross and hover over. So I need to find the intersection where these 2 lines cross, where the orange and the green cross. And if I click there, it tells me -3, -3. That first number is my x number. So I know that x equals -3. Okay. Let's actually skip to example 3. I kind of numbered these weird. let's skip to example 3. Example 3 gives us, hold on just a second. Okay, example 3. I am going to need to change my variables because I don't have x's. So the first thing I'm going to do on example 3 is I'm going to rewrite 3, instead of a, I write x, plus 2 equals negative 6 minus, instead of a, I write x. Okay, easy breezy. I have my two sides. So I have 3x plus 2 is one side, and the other side is negative 6 minus x. So I've got 3x minus 2. I'm sorry, not minus 2, plus 2. Plus 2. And negative 6 minus x. Okay? Now again, I already used these two lines on my last problem, and I don't want to be looking at them right now. So I can just click them away. So I've got my 3x plus 2 and my negative 6 minus x. So I put them on separate lines, and now I need to find where the intersection is and pick my first number. So my intersection and my first number is negative 2, so x equals negative 2. Okay. Next up. Now let's do example 2. So we already have x's, so we don't have to change our variables. We just have to find our different sides and put it into Desmos. Okay. So I know I'm going to have 10 minus 8x, and I'm going to have negative 3x plus 8 minus 5x plus 2. Okay, I'm going to turn these lines off because I don't need them anymore. 10 minus 8x, that's my first side. Negative 3x plus 8 minus 5x plus 2. Okay, so let's see. Now I need to find where they cross. Well, I'm not seeing where they cross. Let me zoom out and see if I miss it. Zoom in. No, not seeing it. Well, let's see this. What if I turn one of the lines off? Oh, see, if I turn the purple line off, now I see the green line. Turn the green line off. Turn the purple line back on, green line back on. These appear to be the same line. That means that all they do is cross. That means that they have infinite solutions. So that's a trick for you to know. If they are the same line, then the answer is x is infinite solutions. Any number of x I can put in there, any number of x is going to make it balanced on both sides. So that's a unique one. Okay, last but not least, let's look at example 4. Whew, we're almost done. Almost did it. Okay, example 4. Let's see if we can do it without the notes. I know that I need to change my variables to x. Negative 2x minus 9 plus 6x equals 14 plus 6x minus 7. Okay, let's see. So now I've got them divided up, or now I've got them switched over to x's. Draw my line, look at my two sides. Negative 2x minus 9 plus 6x, 14 plus 6x minus 7. Let's see. Negative 2x minus 9 plus 6x. Guys, this is a lot of copying and not a lot of actually doing math. So it's tedious, but you can do it. So we have 14 plus 6x minus 7. Okay. And let's change the color of that one. Let's turn them on and change the color so it's easier to see. Let's change it to green. Okay, so now I need to see where they cross, so I'm going to have to kind of zoom out a little bit. Go down. Oh, I see where they cross now. Okay, get close to where they cross, click, and that gray dot will tell you that first number is what x equals. X equals negative 8. Okay, that is the trick. So we could spend our time learning how to do all of this for each problem, or we could spend our time using Desmos to be smart about it and just finding where they're equal. Okay, the practices are on your own. Let me know if you need help.